Section 4.4 is alternative definitions for trig functions. You would use these alternative definitions if you aren't working on the unit circle, but your angle is embedded in a graph. So I'll show you the examples and then kind of talk about when you would use these alternative definitions. We're still using the same core definition. Sine is opposite over hypotenuse, but the alternative definition is y over r. And you use this when your angle is embedded in a graph. Cosine is adjacent over hypotenuse. The alternative definition is x over r. Tangent is opposite over hypotenuse. This is y over x. So you'll notice that the y we had when we were on the unit circle as our definition for sine, but now we have over r because in these cases, the examples we're going to do, r is not 1. R could be anything, where when you're on the unit circle, r is always 1, so we don't include that in the unit circle definitions for sine, cosine, because we don't need it when r is 1. Cosecant is the reciprocal of sine, so it would be hypotenuse over opposite, or r over y. Secant is a reciprocal of cosine, so it would be hypotenuse over adjacent, r over x. And tangent is hypotenuse over opposite, or x over y. So we'll try a couple of examples and use these new definitions. The first one says, let negative 3, 4 be a point on the terminal side of theta. So I'm going to graph negative 3, 4, be right here. And what we're going to do is make a line from the point to the origin. That is the terminal side. And theta is out here. But when we create a triangle with this angle's information, we actually can look inside of the triangle. So I'm going to put a line from the dot to the x-axis. So this is my triangle. And the angle that I will be referring to is inside of the triangle. It is right here. So I can get my side lengths by counting. The bottom side, I just count 1, 2, 3, and that's 3. Because it's back to the left, I will use negative 3. I can get the leg going up, 1, 2, 3, 4 by counting. So that is 4. And then I'd use the Pythagorean theorem to get the hypotenuse. In this case, it is 5. So if I'm going to use my new alternative definitions, I would say that the x side, because this is on the x-axis, is negative 3. The y side, 'cause it's 4, it's up, that would be 4. And then the r is the radius of the circle. If I drew a circle around this, you know, the radius would be from the center to the point on the circle. So r is 5. Now when I find sine, cosine, and tangent, I can use x, y, and r. Sine of theta is y over r, so it would be 4 over 5. Cosine of theta is x over r, so negative 3 over 5. And tangent of theta is y over x, so 4 over negative 3. That negative can sit down there, it's fine, or it can pop up in front of the 4, or it can just be out in front of the whole fraction.